Good morning all of you. Now today we can discuss what is the equation for finding the area of any quadrilateral, any shaped quadrilateral. It will not be any special type quadrilateral. For all types of quadrilateral we can use this method. Okay, we already learned the equation for area of a trapezium. What is that? Area of a trapezium is half into h into a plus b. Okay, or h into a plus b by 2. Okay, and here a and b are the length of the parallel side and h is the distance between that two parallel sides. Okay, that all of you remember. Okay, next another equation for finding the area of any type of quadrilateral. For that we draw a quadrilateral PQRS and first we divide this quadrilateral into two triangles. First triangle we can take it as QPS and another triangle QRS. Okay, so for finding the area of this quadrilateral, we only need to find the area of these two triangles separately and take their sum. Okay, that equation we already know. What is the equation for finding area of a triangle? That is half into base into height. So using that equation, first we can find out the area of this triangle QPS. What is the area of the triangle QPS? Its base will be this part. Okay, that is equal to half into QS into height, we can take it as H1. This take it as H1. Just like what is the area of triangle QRS? The second triangle QRS, its area will be half into, in this case also the base is the same, QS into height is here H2. Okay, so what will be the area of the quadrilateral? Therefore, the area of the quadrilateral equal, find the sum of these two. That means half into QS into H1 plus half into QS into H2. Okay, QS is the side, so both should be capital. So here in both terms, which is the common, half is common and the base QS also common. So half into QS into, then here remains H1. First term remains H1 and the second term remains H2. Okay, so when we consider this QS, what is the mean when we consider this quadrilateral, the QS is what? That QS is, we can take it as a diagonal. Okay, so when we draw any quadrilateral, in the case of a rectangle also, if we draw a rectangle and when we draw a line segment from one vertex to its opposite vertex, it will be the diagonal of that rectangle. So in this case also, for this quadrilateral, when we draw a line segment from one vertex to its opposite vertex, it will be the diagonal of that. Okay, so instead of that QS, we can mark it as D, where D is the length of this diagonal. Okay, so that is half into QS is this length, that we can take it as the diagonal D, half into D into H1 plus H2. H1 plus H2. So this is the equation for finding the area of general quadrilateral. Half into diagonal, it's diagonal into H1 plus H2, where H1 and H2 are the heights of these two triangles, height of this vertex from these two triangles to the base. Okay, so this is the equation for finding area of a general quadrilateral. So all equations want to be by heart. First we learned the equation for finding area of a trapezium, that is half into h into a plus b. Okay, here area of the quadrilateral is half into d into h1 plus h2, where d is the diagonal and h1 and h2 are the corresponding heights. Okay, now one more equation for area of rhombus, that also we can discuss today. What is area of rhombus? Rhombus, we know, for a rhombus all sides will be equal. What is equation for finding area of a rhombus? All sides will be equal for a rhombus. So in this case also, we are split that rhombus into two triangles. Okay, and mark the heights for both. Here this is the height, so this angle will be 90 degree, and in this case here we can this we can take the height. Here also will be 90 degree. So we can give the name A, B, C, D. So for finding the area of this rhombus, here also we are using we are splitting the area of triangle ABC. Okay, triangle ABC and triangle ADC. Okay, so first we can write area of triangle ABC, we can find out. Okay, area of triangle ABC. Triangle ABC. Here also, what is the equation for finding area of a triangle? Half into base into height. So half into, here the base is AC. AC into height. Here, if the intersecting point, that is when we two diagonals, when we draw the intersecting point, we can mark it as O. Okay, so its height, this will be the height of this triangle, and that is BO will be the height of the triangle ABC, and DO will be the height of the triangle ADC. Okay, so when we find the area of the triangle ABC, when we consider only this triangle, its area is half into AC into its height is OB, okay, or BO. Just like what is the area of the triangle ADC, that's equal to half into, here also the base is AC, AC into its height is OD, okay, OC and OD. Now, therefore the area of this full rhombus will be, when we take their sum, add the two areas. So area of this rhombus equal, area of rhombus equal half into AC into OB plus half into AC into OD. Okay, so that's equal to, take the common parts outside, half AC is common in both. Okay, so that's into, what is remaining in the first term? OB plus, what is remaining in the second term? OD. Okay, so that we know when we look at the figure, OB plus OD, what is its length? OB plus OD, it is the diagonal BD. Okay, OB plus OD, the distance from OB plus distance from OD, the totally we can take it as the distance as BD. So this we can write it as, this is equal to half into AC into BD, that is clear. BO plus OD we can take it as BD. Now you look, when we consider this figure, AC will be one diagonal and BD is another diagonal. So what is, we can, instead of this AC we can write it as D1, and instead of BD we can write it as D2. So the area of a rhombus equal half into D1 D2, where D1 and D2 are the diagonals of that rhombus. Okay, so totally we learned three equations for area. One is trapezium, second one is general quadrilateral, and third one is rhombus. Very important, all of you by heart the equations. Okay, now take the exercise question. First question that we already done. Now today we want to, fourth question, we can discuss the fourth question. The diagonal of a quadrilateral shaped field is, I will give this clue, all of you want to do the questions you want to answer full in your notebook. Okay, answers, question and answers. The diagonal of a quadrilateral shaped field is 24 meter and the perpendicular dropped on it from the remaining opposite vertices are 8 meter and 13 meter. Find the area of the field. Okay, so in this question it is given, directly given, all the points is given. That is when we consider this general quadrilateral, that we know this equation also we know what is the equation for finding general area of a general quadrilateral. That is half into D into H1 plus H2, half into D into H1 plus H2. So here D is what? 24 and H1 is 13 and H2 is 8. So using that you can find out its answer. Next question. The diagonal of a rhombus are, so for writing any, if you are finding the area of any shape, first you write its general equation. After that only write its, substitute the value. Okay. Next, fifth question. The diagonal of a rhombus are 7.5 centimeter and 12 centimeter. diagonals. So D1 is 7.5, D1 is given 7.5, D2 is given how much? 12 centimeter. So find the area. This is also direct equation. What is the equation of area of rhombus? Half into D1 D2. So half into 7.5 into 12. Okay. Next question. Find the area. Sixth question. Listen. Read the question. Find the area of a rhombus whose side is 5 centimeter and whose altitude is 4.8 centimeter. Okay. A rhombus is given and its side is given how much? 5 centimeter. So all sides are 5 centimeter and its altitude is 4.8 centimeter. Okay. Now if one of its diagonal is 8 centimeter. Okay. If one of its diagonal is 8 centimeter. What is the question? Find the length of the other diagonal. What is its? One is given its side, that is if it is one side is 5 then all sides will be 5, and its height also given, that means the height means from the vertex perpendicular distance to here. So its height is given how much? That is given 4.8. Is it? Where is? Okay, 4.8 centimeter. Now here it is not given, but we know, we all only learned what is the equation for finding area of a rhombus. Its equation we know, half into D1 into D2. Okay, if you know the diagonals of the rhombus, it is very easy. We only need to substitute that. But here diagonals are not given. Then how we can find out its area? But only one diagonal is given last. But listen. Find the area of a rhombus whose side is 5 centimeter and whose altitude is 4.8 centimeter. If one of its diagonal is 8 centimeter, one diagonal is given 8 centimeter, then how we can find out the length of the other diagonal? Is it possible? How we can find out the area of this rhombus? Here height is given and one side is given. So we know all rhombuses are parallelogram. That we know. All rhombuses are parallelogram. So using the equation of a area of parallelogram, first we can find out the area of this rhombus. What is the equation of area of a parallelogram? Base into height. So area of parallelogram is base into height. So for same equation we can use for the finding area of rhombus also. So area equal base into height. Base we know that is 5. 5 into height is given 4.8. Okay, so its value will be 24. So 24 centimeter square is the area of this rhombus. Now next it is given, if one of its diagonal length is given how much? 8 centimeter. D1 is given 8 centimeter. Then what will be D2? That we want to find out. For finding D2, then we can use the equation of area of a rhombus. That we already know, area of a rhombus is half into D1 into D2. Okay, we got the area as 24. So substitute that value here. 24 equal half into one diagonal also given 8 into D2. From here it is very easy to find out the length of the second diagonal. D2 equal 2 when we transpose to here, 2 into 24 then divide by 8. Okay. Now after calculation you will get 6 centimeter. Okay, by cancellation you will get it is 4. 24 by 4, 6 centimeter. So this way, if it is not directly given, we want to use another method for finding its area. Then another, if it is asked to find out, that we can easily find out. Okay, next two questions you can do as homework. Okay, thank you.